Hello and welcome to another math video. We're talking about the volume of pyramids and cones this time. Well, in order to talk about the volume of pyramids and cones, we have to compare them to the volume of right prisms and cylinders. So when I think about the volume of a right prism, the volume of a right prism is length times width times height. And the volume of a pyramid, you may not know this, but I can fit, if I chop this up appropriately, I can fit 3 pyramids into a right prism if they have the exact same length, width, and height. And so what that means is the volume of a right prism is 3 times larger than the volume of a pyramid. Or another way of thinking about that is the volume of a pyramid is 3 times smaller than the volume of a right prism. So the volume of a pyramid is length times width times height divided by 3. Now this is going to come in really handy a little bit later on. Similarly, we can think about a right cylinder and a right cone. A right cylinder is just a circle that's been stretched perpendicularly vertically, and then a right cone. As long as it has the exact same dimensions, it's a very similar concept. If I chop up this right cone into enough pieces, I can end up fitting 3 of them into the cylinder. So I can fit 3 of those right cones into the same dimensioned cylinder. Well, what's the volume of a right cylinder? The volume of a cylinder, okay, it's the area of the base times the height, and the base is pi r squared. So the volume ends up being pi r squared h. We already knew that. So if the volume of a cylinder is 3 times larger than the volume of a cone, then that means the volume of cone is 3 times smaller than the volume of a cylinder. So that means our formula for the volume of a cone is volume is pi r squared h divided by 3. So let's use our newfound equations to be able to calculate the volume of this pyramid. So this is a square-based pyramid. That means the dimensions across the bases are equal. So 4 millimeters. This is a pretty small pyramid, but that's okay. It says, what is the volume? Okay, so it's length times width times height divided by 3. Well, we know what the length is. That's 4 millimeters. We know the width is. That's 4 millimeters. We know what the height is. That's 2.1 millimeters. Sorry. And so we just have to divide that by 3. When I put that into my calculator, I end up getting 11.2. And since it's millimeters times millimeters times millimeters, I get millimeters cubed. All right, not so bad. This next problem doesn't look so bad either. Find the volume, round to the nearest tenth of a cubic centimeter. So what we want to do is we want to find the volume, okay? We want to go volume is length times width times height divided by 3. Let's ask ourselves, do we have the length? Yes, it's 18.5 centimeters. Do we have the width? Yes, it's 18.5 centimeters. Do we have the the height? No. No, we don't. We have the slant height, but we don't actually have the height from the center of the pyramid. Let's redraw this. Let's redraw this from a perspective looking straight at the pyramid. So the pyramid's going to look something like this. And we want the height, but we're not given the height. We're given the slant height. It's 25.6 centimeters. Well, we want the height. We know that all the way across the bottom is 18.5 centimeters. We can solve this problem though. It's not that big of a deal. We just need to know a little bit about Pythagorean theorem. Pythagorean theorem tells us that the two legs of a right angle triangle, when we square them and then take their sum, that it should be equal to the square of the hypotenuse of the right angle triangle. Let's write that down. I'm sure you know this. A squared plus B squared equals C squared. Now, H looks like our A, so H squared. B is whatever this leg is, and that's half of 18.5, so 9.25 squared. And it equals C squared, which is 25.6 all squared. If I want to get H, which is the height out of this, if I want to get H, I'm going to subtract 9.25 squared from both sides. So I end up getting H squared equals 25.6 squared minus 9.25 squared. And then I have to take the square root of both of these sides. So H is going to be the square root of 25.6 squared minus 9.25 squared. And I end up, for a value of the height of this pyramid, I end up with 23.8704,315, blah, 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 centimeters. We're going to take that value, that unrounded value, and we're going to use that in our height. Okay, no problem. We know the length, that's 18.5. We know the width, that's 18.5. We know the height, that's 23.87 dot, 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 divided by 3. So if I go 18.5 times my answer times 18.5 again divided by 3, I should get 2,723.218394. It was centimeters times centimeters times centimeters, so centimeters cubed. And I want to just look up back to the original question, round the answer to the nearest tenth of a cubic centimeter. So this is our tenth right here. So our proper answer is going to be 2,723.2 cubic centimeters. That is the volume of our pyramid. Some similar ideas here for the volume of a cone. We already went over this. The volume of a cone is pi r squared h divided by 3. Let's see, we know what pi is, we know what radius is in this example, it's 5.1 meters, and we know what the height is, it's 14 meters. Okay, so this is a pretty easy calculation. Pi r squared, so 5.1 squared, times h, which is 14, all divided by 3. So if I put this into my calculator, I'm going to get, I'm going to get meters squared times meters, which is meters cubed. When I put this into my calculator, I get 381.3 something, 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 something. It says round to the nearest hundredth. So I should be a little bit more specific. It was 32651 blah, 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 meters cubed. Our hundredth is right here. That's the 2. And since the next value is a 5 or higher, we got to round it up to a 3. So this will be 381.33 cubic meters. And our last example for this video, we've got a cone here. Okay, says find the volume, round to the nearest tenth of a cubic meter. So the volume of a cone is pi r squared h divided by 3. Let's see, we know what pi is, we know what the radius is, but we do not know what the height is in this example. The 15 meters isn't referring to the height. Height's over here. It's this distance. We're not given the height, we're given the slant height. We're given from here to here is 15.0 meters. So, well, hopefully, I don't know, hopefully this makes sense. We're going to have to do another Pythagorean theorem, so I'm just going to make some room on the side. When I look at this, the relationship is that h squared plus 7 squared is equal to 15 squared. So h squared plus 7 squared is equal to 15 squared. So that was my a squared plus b squared equals c squared. If I want h squared, I subtract the 7 squared to the other side. So h equals 15 squared minus 7 squared. And then if I want to get h by itself, I square root both sides. The square root of 15 squared minus 7 squared. And when I do that calculation, I get 13.2664 blah, 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 blah meters. So I'm going to use this unrounded value and I'm going to insert it into my equation now that I know what the height is. Okay. Volume is pi r squared, so 7 squared times h. And our h is the value we just got, 13.2664, blah, 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 divided by 3. So when I do this calculation, I end up getting 680.7396 blah, 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 cubic meters. And it says, remember, we wanted to round to a tenth. This is my tenth right here. So the 7, because the next digit is a 3 or lower, we're going to keep it as a 7. Okay, so we're going to get 680.7 meters cubed. Perfect. Hope that helps.